use a built up, but similarly, you could, using those design actual load, you could just choose the members. That you have all AISC row sections. You choose the members, and then you could just check with the design load versus capacity, and you could size the column. Some of them, we obviously this case we have we need bigger, because the row maximum big row section is in United States produces 14 by 730. More than that, heavier than that, we need to use a steel plate and weld it on each side of WS14s, or totally built up section we have to use. So you see that capacity still we don't meet yet. So so that means the 40-story building with the 40 feet by 30 feet typically need probably built up section. And then move down, you could see that you could find out maybe right size. So this is a still column design module. You could just play around and find out the shape to meet the demand capacity ratio. So you understand this is trapped area for each column, right? And associate trapped area for each column. So I think your final project, and you should maybe design maybe one interior column and one exterior column. You could choose one, maybe, or two. So this design module, especially since we are using steel column, right? The ETAPS can design that also column. Similarly, using steel a section module, not composite beam module. So, for example, those column we assign as auto selection in auto lateral column. Instead of using composite beam design module, we're gonna use a steel frame design module. Similarly, so once we create the lateral model, entire model, and run it, and we'll calculate all the column actual force, and once we confirm that column force, we're gonna use ETAPS to design. So maybe I can gonna move to.
Professor, going back to the spreadsheet.
Yeah.
For the steel column design. So you said anything above 14 by 730 would require moment frames?
Mm-hmm. So this case is something unique, because if this is obviously a small building, you could find that walkable W14, right? Because now our forces here 10,000 kips, right? Okay, here's a column reactions, all the column force. Okay. So even though our heavy section here, right, you see that is 25% exceeded over stress, because this W14 by 740 is not enough for our force. So typically, after this, if you want to keep using there is two choice. This is now design. So if you want to use a roll section, the roll section you're procure a heavy section is, let's say, 14 by 730. Just we could use the 14 by 730, and then additionally we could put the steel plate on each side, right? Mm-hmm. So in this case we have to increase the area, but how we do it? This is the one way to do this. Be using roll section as a base, add an additional steel plate, so max box shape. So the basically increasing area of steel to meet increase our actual capacity. So So this is just one way using roll section, or instead of using roll section, you just use the whole entire plate, right? You could use the entire plate using full plate, weld it together, make a box shape, and you can use a box shape like this. So there's a few. This is more detail related, but obviously area of the steel is the key. That for actual capacity design. Let's see here. Oh, okay. Area of steel is, yeah, 215 inches square. It's not efficient to meet this. So this case, you need an additional steel plate. Or one more thing we could do these days, we have 65 KSI steel. Maybe you could try this. Okay. If you want to use roll section, there is another higher steel, 65 KSI instead of 50. I think it's 0.99, so you could use that too. So I think, but now practical the procurement in United States refinery steel industry, I don't think they produce 14 by 730. It's hard to procure these days. So I think you typically contractors would know that which section is available with which steel grade in United States. These you know that Hudson Yard project, there's some steel actually ship it from I think Denmark, from Europe, where they produced heavy sections with the high strength steel. But I think here you see that there are a couple of choices a structural engineer has to choose based on that design force and capacity. Okay. So I'm gonna open the lateral model. I think this is what we're doing. I think maybe I could have another session on this Thursday because I think lateral system is I think your current model, let's say, you just copy it, but don't have any. Let me see how many. Okay. Hold on. Yes, yeah. After you copy it and diaphragms, I think you haven't defined more wall properties and beam properties with the various concrete strengths. So what I tried to explain, now we haven't sized any wall for the lateral. We have to start doing it. So let's say we may need a 30-inch thick wall as high as 8 KSI. So you have to start, you may to create young concrete strength material. Gosh, same thing. So you have to create all 5,000, 6,000, 7,000, 8,000, and also you have to create the section properties, wall thickness, and then you have to link that material properties based on the thickness, and material has to go always together based on your design criteria and engineers intent. So we have to size up. I think the last couple of last class I explained I few. Let me just show you. So this is example, right? So typically only just concrete core wall. I define a set of wall thickness and also concrete strength. So this is just I think both all the model should need that sizing and design. Here that I think this color coded column is different wall thickness. Just use color coded by the wall thickness. We could do by the concrete strength too, but eventually we have to define various concrete wall thickness and material. So once you set up, I think now you did. We haven't done yet. So section even though section properties turn on, you see that everything is the same size. Obviously, you just copy all the way up. Now, one thing that I have to explain here, the diaphragm. So I think somehow you guys see maybe while you're copying, so you mesh the wall so that there is an internal mesh here. So that has some issue. If you do this, you have to do carefully. So few stuff I'm gonna point out. Maybe I can delete it and then redo it. So here, right? So go back to the first floor. You assign the one diaphragm. I think it's okay. But when you choose like this, okay, I'm selecting all the members. Maybe I'm putting okay, maybe. Okay, let me try here. Oh, not here. Okay, the one thing you have to always okay, when you select all the maybe any elements on the plan, take a look at it. It select all the nodes, the floor below. So you select all these nodes, intermediate nodes, right? So if you have any intermediate nodes, the ETAP says select all the nodes together. So if you assign, let me just try, because this is important because diaphragm and it changed the behavior. So let me just turn off the diaphragm. I'm gonna delete the old diaphragm. So no diaphragm, right? And then I'm gonna select all the nodes to assign the diaphragm. See that all the nodes are selected here. So if you assign the diaphragm, if you assign joints and assign the diaphragm E1,